Hello, everybody. Welcome to Hurricane Center Live. This is amazingly our 7th season, our 144th episode of Hurricane Center Live. We've been doing this a while. We were all much younger, had more hair or hair with color when it started. Goes back a while. Joe Cione is going to be our guest here in just a couple of minutes. But first, let's thank our sponsors who make these shows a reality each and every week. USAA, the South Padre Island Convention and Visitors Bureau, Live View, and the Texas Weather Network. Hey, we appreciate y'all. We couldn't do it without you. All the sponsors over the years have been really important, and USAA and the South Padre Island Convention and Visitors Bureau have been there since the very beginning. We appreciate that. Someone else who's been there since the very beginning of time, almost, Bill Reed, former director of the National Hurricane Center. Good morning, Bill. The breeze blowing behind you there. How are you?
Doing fine. So you've been spying on my ancestry, and you've seen that I have a small percentage of Neanderthal in it. But here we are in the dog days of summer right now. Last week of July, first week or two of August are climatologically the hottest. When I worked in San Antonio, a forecaster, a colleague of mine, always referred to this time of the year as the season of great sameness. And we live here can relate to that.
Understood. So the weekly question, what's your dew point? Mine's about 80 right now. How are you doing on that?
75. It's down a degree or two from earlier this week.
Well, and our guest could chime in on that in just a second. So, before the show, Alex and I were talking about, and Alex Garcia is back in Mission Control, about how we started this during the pandemic because we had to have a way to get the message out. So 2020 was our first season, and now we're 144 episodes in. It's amazing. Some of the things we've talked about, some of the folks we've had on.
Very good.
So take it away. Introduce our guest, and let's get to it.
All right. Well, backed by popular demand, is one of our good friends of the NTWC suite of events, including our conference down on South Padre Island. Is a research scientist with NOAA, the Hurricane Research Division, who specializes in observations and studying the results of some of those observations, and especially how they pertain to operations on the aircraft, the P3s there. And he's joining us from Lakeland, where he was in an interesting experiment just recently. So welcome, Joe Cione, to our show.
Thank you, Bill. Thanks for having me, Alex and Tim, and really happy to be part of this, I would say, legendary show at this point. You guys are going strong here for a lot of years, and a lot of listeners, and looking forward to interacting with you again today.
Great. So my first question was going to be, what are you up to these days? You've already told me, so why don't you tell the audience exactly what you were doing to pry you out of vacation to come down and fly?
Yeah, I was on leave. This is a time, I know the hurricane season starts on June 1, but typically doesn't really get going until, we get into August or so typically. Or maybe I just jinxed things. And this year with the El Nino, we could be looking at even less storms on average. So I figured July was a good time to take some time off, but I'm always keeping my eye to the sky and see what happens. And we had an opportunity to do a test off North Carolina. They have some special buoys there that are an array that can actually measure turbulence and measure fluxes of heat, momentum, and moisture. And one of our drones that we dropped from the P3, our really workhorse drone, the S0, built by a company in Black Swift out where I live in Colorado. They said, hey, look, we have some flight hours, the P3 does. Our emerging tech team said, you want to do it? There was a short window when we picked it up. And I said, okay, I'll dump my vacation. I flew down to Florida. And we flew yesterday into that array and compared the direct fluxes between what we were measuring and what these buoys are measuring. So to calibrate it, really, why we want to calibrate what we're doing, it's very hard to get direct measurements of flux like that. But we're also interested in a bigger picture sense to improve the numerical models. A lot of the numerical models, people that are modelers that are listening out there, the models use these transfer coefficients, and they're kind of guesses at what's happening with energy and momentum. And if we can actually know what the actual fluxes are doing, we have a chance to collapse that uncertainty. So we're not in a hurricane environment, but these types of observations get us a step closer to improving the numerical models.
Yeah, that is kind of interesting. How accurate are those data buoys? Do you know?
Very accurate. they were used in Toga Core 3. So they're constantly calibrated, and they're pretty much the gold standard for that. So the question is, how well are ours calibrated to that? And that's what we're doing. We spent a lot of time calibrating our measurements too. We were going to drop sondes. They also measure, standard net observations, and we had some string sondes, which are the next generation drop sondes that were swarmable drop sondes, if you will. Think of like Twister, where we can throw up close to 50 of those. So we were going to drop some of those as well to just give us some more observations.
Wow, that's great. I think that's important that you can get some idea of how well calibrated the drone is over a network like that, because you're not going to usually have that network lying under the path of a big hurricane.
No, not at all. Not at all. Never would be the case, unless, I guess, we're up. This was right off Kill Devil Hills and Kitty Hawk, about 10, 15 miles offshore. So you kind of physically know where we were. It's pretty. Those buoys are pretty amazing because they're moored, and if you know your oceanography, the Gulf Stream's there, and a Gulf Stream moving pretty quickly is usually not very friendly to things that want to stay stationary. So, but they've managed to do it for a number of years.
Very cool. So, how have you seen any results in modeling where they perhaps simulate this kind of data as to how much it would improve forecast? Well,
that's a great segue there. Not particularly with the flux stuff, but we have been operating these S0 drones now for 2 years pretty regularly. We dropped about 40 of them in about 10 hurricanes spanning, but as I said, between 2024 and 2025. And our team at HRD that looks at data assimilation and data impacts has taken all these data, with and without data denial, and we are looking at, and without, I should add, not very sexy, in a great way, but just very, very basic, just taking the data out, taking the data in. And we're looking at somewhere between 10 and 20% increase in HAFS intensity forecast right now. And we think that's the floor. So these drones are making a huge difference already, and they are, for the first year, this year, your viewers will be interested to hear this, are going to be incorporated in HAFS this year. And that's really remarkable to get it in the models, because usually, the models are like, do no harm, and they're comfortable. They know there's not going to be any harm with this. So we're going to be operationally in HAFS this year, and also in AWIP spill. This system quite well at the Hurricane Center. We were in the cloud. So there's two versions of AWIPS. There's a cloud version, and then there's the operational version. And now we're going to be these drone observations are going to be in AWIPS operational this year, working with Mark DiMaria, who is a name many of you know as well, who is going to reduce, working with James Franklin, another name that people may know very well. We're going to reduce wherever we are, 100 meters, 200 meters, because we're never flying quite at 10 meters, but the Hurricane Center is interested at that. So we're developing some AI and some statistical methodologies based on James's old work, and also some new AI procedures, and we're going to have a product that will give the 10-meter wind no matter what altitude we're flying at or where we're flying in the storm with the drone. So we're very excited about that.
Yeah, and it's been a long while since I retired, obviously, but I think in the entire time I was there, you guys may have launched 3 drones.
Yeah.
That's all you had. I mean, you would have gladly launched more. So what scaling up, since this has a proven benefit, how many drones do you think you'll have to operate with like now and then maybe 5 years from now?
Yeah, so we were a little disappointed. We thought we'd have more drones this year because we've shown such great progress each year. So we've had about 20 in the last 2 years. This year, we're ramping it up to about 30, maybe 35 or so. But if you want to think about, maybe there's 20 or so, well, let's say about 10 hurricanes in an active year that we can sample with the P3s. And if you figure maybe 4 flights or so per, so we're looking at 40. And then this year, I didn't mention it, but we're able to drop 2 drones at once, which is a big advancement for us. We've never been able to do that. So you're looking at probably, on the order of 80 to maybe 100 drones per plane. So I would say in 5 years, I would like to see us have 150 to 200 drones a year. So we would think of them as what we routinely drops-ons, maybe not drop that many, but drop a couple of drones in pretty much every storm that we fly in with the P3, with the C-130s, and get us to the point where we can do with the Air Force too. Right now, we're not doing it with the Air Force. There's some technical hurdles there with them. But I say within 5 to 7 years, Bill, we could be looking at hundreds of these things per season.
Fantastic. Once launched, how much time do you have on station for one of the drones?
It's amazing when, you were mentioning the early drones we dropped in 2014 or so. That was really the beginning days of this. And, we would have maybe 25 minutes and we would only be able to fly about 10, 15 miles from the deployment P3 aircraft, which was problematic to say the least. So now Black Swift has really, and working with NCAR and folks like Terry Hoke, who is the godfather of the Dropson, and using some of the Dropsons can communicate about 200 kilometers at least. So I went to him first and said, hey, you're both in Colorado, Black Swift, let's talk to Terry. Terry's going to give us some tips on how to go farther. And that was the biggest advancement we've had. Now the drones can communicate 250 nautical miles away from the P3. And it's an amazing engineering feat, but it's a critical one from an operational standpoint because the P3 can do its operational missions and not babysit and just let the drone do its work. So we can go very far. We can go for 2 hours or so instead of 20 minutes. And the price too has dropped. So we're probably in the order of about 18 grand at where we're making these in the 10s and 20s. And we think that can get down to maybe 13 grand and maybe have 2.5 hours in the future. So it's getting better and better and better. If you think of a Dropson, Dropson is $1,200 for 5 minutes. Mm-hmm. Best deal. But we do it. We don't think twice about it. So, I'm trying to convince our bean counters here a little bit to say, don't look at the number. Don't say 12,000 and your head explodes. Think about how much time we're out there. Think about we're measuring where we cannot measure. You have a Dropson right below the plane. This is so you're putting maybe pinpricks in a donut, right? The donut is the eye wall. But now we're able to carve out the entire donut. And go, in the areas where we're going to get the maximum winds, in the areas where we're going to need the forecast to help save lives, protect people. So I think the future is incredibly bright, especially that I mentioned that the impact already is being seen, and that's just with a few data points. If we can make sizable impacts on the forecasting and also the situational awareness. Bill, this is near to your heart, I'm sure. If you have a limited number of observations, you're I won't say guessing, that's a little harsh, but you're guessing a little bit as to what the max winds might be because you're not measuring everywhere. And with the drones, you're still not measuring everywhere, but you're measuring a whole lot more places. And I think we have the ability to get at that absolute maximum wind or closer to it. Say, instead of the median value of where the winds are, that's probably what we're doing now. Maybe we can give you 1 or 2 standard deviations to the right. So maybe, in the 95 percentile of where the max winds are. And that is the difference between evacuating an area and not. So we're very excited about this technology. It's only one of the emerging technologies we're looking at, but it's very exciting and it's the closest to being operationally implemented in a way that we're going to be using it all the time, hopefully very soon.
Interesting. So the flight patterns for that mainly in the eye wall or the core, or do you go out to try to measure how far the hurricane force winds go out, for example?
Yes, we can do both. So we have these automated plans where we can adjust the flights too, but we have these what we call modules. That is an inflow module. So that gets to the radius of maximum wind for sure, the radius of hurricane, and then probably the
looks like we got a freeze.
I think we may have lost Joe. Yeah, well, let's see if we can get him back. And Bill, go ahead and do your tropical update, and then we'll get back to Joe. Hopefully, we'll get him reconnected.
Okay, I'll do the tropical, and then you can do the sponsors, and hopefully, we have Joe back on the live action.
You got it.
Okay, as I always headline this, when you're watching this, everything I'm telling you is outdated. So go to official sources for what's actually going on with what I'm talking about in the tropics. Okay, I'll go share. Let's see where we go. Okay. Unusual for me is instead of starting off with near and dear to home, I'm starting off out in the middle of the Pacific Ocean. There's a super typhoon that went through some spectacular rapid intensification on Tuesday, the 27th or 28th, and then now is holding it super typhoon, and the forecast from the Joint Typhoon Warning Center is stay in the super typhoon category at least 4 days. Super typhoon is roughly equivalent to the Category 5 status we give storms over here. Luckily, it's where its trend is over the vast Pacific Ocean is that at least for 8 or 9 days the track is over water. And as you all know, we're a little careful about forecasting too much in the specifics when you get out beyond 5 days. So stay tuned, watch your sources if you have interests out in Asia, for example, or any of the islands approaching Asia for future on that. This is the current loop. It's updating real quick there, but the pinks in there are very cold cloud tops, which is one of the key signatures for a very powerful eye wall. And of course, the cleared out eye and measurements they make of that are what allow them to use satellite techniques to get a very accurate estimate of how intense these really intense hurricanes and typhoons are doing. Just one quick shot to show you we tell you not to look at the line, so what do? I put up a graphic with the line on it, but I'm sure you guys that are watching this and gals that are more intelligent than to worry about the median of that. But this is from the 1,000 ensemble run of the DeepMind AI forecast, and you can see the spread of all the things anywhere from Japan to Taiwan and China. So you can't really give people actionable intelligence. Just keep paying attention. Back in our part of the world, we've been watching 2 storms over the Eastern Pacific for the last week or so on Fausto. This is the dying embers of Fausto moving to the west-northwest past the islands as a depression this morning. And it'll take it a while to fully spin down, but it's pretty much gone. And Genevieve, which was a powerful hurricane, reached Category 5 status for a while. It's still a hurricane, but it's showing signs of ingesting the dry air. It's moving over into more stable air and over eventually cooler waters. Again, no effect to land, staying out to sea, and will have a similar fate to Fausto. And looking at the models, there's really nothing in the food chain in the next 7 to 10 days out that way. So maybe we'll have some quiet for the folks in the Pacific side. The Atlantic is dry and dusty, as you can see in this animation this morning. The stable dry air coming off the African coast, the waves are almost non-existent as far as convection. Really strong trade winds across the Caribbean, and not shown here a lot, but you can kind of see it with some cirrus clouds there. There's some pretty decent westerlies there, so there's sort of hostile shear environment, hostile dry air environment. And I said way too many words to say nothing's expected for the next week to 10 days on that, which is consistent with what NHC has out. And the infamous runs of the Google DeepMind, this is of 1,000 iterations, and it's got 1 or 2 tracks here, 1 or 2 there. What that really means is there's a less than 1% chance that anything's going to show up in the 10-day or 16-day iteration of that. So, Tim, there you go.
That's what we like to see, Bill. That's a nice, quiet Atlantic. And notice the long-range outlook say it stays quiet into next week as well. So let's keep that going. I like that. Thanks, Bill. Good update. Quick break to thank our sponsors who make this show a possibility week in and week out. USAA, sponsors from day one, and we appreciate that. The South Padre Island Convention and Visitors Bureau, We do our conference live on South Padre Island every year in the month of April. We encourage you to join us live if you get the opportunity. In 2027, we'll be at the Hilton Garden Inn. We did the conference there a couple of times a few years ago, so we encourage you to pop out if you can join us there. LiveView, who's part of the program for a long time, they help us do our live broadcast to folks like me and Alex and others who broadcast back to our home markets, and we appreciate that. And the Texas Weather Network, a new part of what we're doing here. Let's get back to Joe Cione now. Joe, you presented before and you showed us pictures of these great drones and things like that, but give us an idea for those who haven't seen them, what we're looking at, how big these are, how they're powered, how they communicate, so on and so forth.
Yeah, sure. Sorry about that disconnection there. I thought I was in a stable environment here at the Hilton Garden Inn, I might add. So very
speaking of which, yeah.
So they are not big. These are the P3s and C-130s have these tubes in there called common launch tubes, and they have been deploying AXBTs, which are ocean probes, for decades and decades. Remember, these are military planes, and they were used essentially to deploy to see how to detect enemy subs. So when we have the P3, we said, all right, this is what you have. Okay, fit something that makes it get out of here, right? So that deployment technique is there because it's always been there. The actual drone itself, though, is pretty small. These are about 5 feet. 4 feet in wingspan, a little bit less than that, and about 3 feet in length. So the wingspan is a little bit longer than the length of the aircraft, and they're only 3 pounds. So these are really, really, really light, but they have a dual GPS, so they're very accurate. They have a multi-hole probe on there, something that this multi-hole probe 10, 15 years ago would have been 10 times as big and 20 times the cost. So this is a good example of technology really getting shrunk down, made by the manufacturer too. So this is not an off-the-shelf thing. The Black Swift company that makes this is the one that also has this. Measures, of course, pressure, temperature, wind, humidity. We're using the same sensors that are used on the balloons, the bisolar balloons, and the dropsondes. So we have the gold standards there. And it also has a laser. We did have a laser, I say radar altimeter on there, very small. Again, technology that's on your car when you're driving and all of a sudden, it stops you from going, whatever it is. That technology has shrunk and gotten so cheap that we can use it on a 3-pound aircraft now. So that's amazing as well. That gives us wave information. So we can use it scientifically, but what's also used when we fly very low and it says 10 meters, well, 10 meters where? 10 meters at the crest of the wave, at the bottom of the wave. So we have to know exactly where we are. So that radar altimeter has been extremely useful to us. So that's pretty much what we have. As I said before I got cut off before, they fly about 2 hours. They are air deployed. Obviously, they come from the P3. Eventually, I'd like to have them from different aircraft. And we can fly in very, very turbulent conditions. People say, well, how the heck is that possible? Think of it as like a stick in the river. Like when I was a kid, I used to throw a little boat, a very quick moving stream, and kind of ride my bike and follow it. The boat never broke. It bounced and maybe disappeared and went underwater a couple of times, but it kind of followed the turbulence. And that's really what we do. So when people say, how did these survive? We just go with the wind, with one exception. So I made a mistake a couple of years ago and said we were lost comms, and when there's lost communications, the drone has to, from a safety standpoint, go back to the center. Well, that's what we had in our routine. Well, it was going back to the center, going the wrong way. So we went into the wind, and all of a sudden we said, wait a minute, it's actually working. And the winds were about 150 miles an hour, so the thing was flying backwards. And we were basically close to stationary or slightly flying backwards. And we said, oh my goodness, now we can measure instead of a Lagrangian way. Imagine going around and around, think of a smoke plume, right? But now we can measure it in Eulerian, and we can be a tower. So I named this the Mobile Ocean Tower Sampling Strategy. So we can park it, hit, and let's say if there's something in the northwest quadrant, we can go to it and stop. Pretty much stop. Not exactly. The winds are going to push us a little bit, but relatively speaking, and then go up and down. So we have these mobile ocean towers now, in addition to the Lagrangian way where we're measuring, and NHC is like losing its mind over this. They're super excited. So we're super excited too, because we can also pinpoint where the P3 is going to overfly us now. Before it was a crapshoot. Remember, we're doing our thing and the P3 is doing its thing. But now we know a P3 is going to come on a leg. We can stop. and they can drop dropsons on us to validate what we're doing, or to pepper some sort of feature that NHC or EMC or OMD, now it's not EMC anymore, wants, right? So that's been a big advancement for us. And we only did that last year for the first time. So now we're going to try to do it routinely this year.
Now, do you program the drone to do that, or can you actually adjust it from the aircraft while it's flying?
Yes, so we can do both. We can just, our longer term plan is to have NHC and EMC say, and by the way, Google DeepMind, we want an AI modeling. Is no longer just numerical models, as you all know. There's an AI component to this. So we want the AI and model, let's just call it forecast world, to tell us what they want. And we're going to design very simple. Going forward, we want it to be simple. So it's routine. Push a button. We want an eyewall circumnavigation, and that means it goes around at 3,000 feet, then drops to 2, then drops to 1. It's whatever they want. So it totally can be pre-programmed. It's still using AI. It's not like it goes 30 miles and makes a circle. It sniffs out where to go. So, for example, we drop it in the eyewall. The drone says, okay, I'm going to radially keep going out because I know the eyewall is there. Pressure's low on my left and pressure's increasing on my right until you kind of merge onto the superhighway of the eyewall, and it keeps going until the winds slightly decrease. And what did we just find? You just found your radius of maximum wind. And then it keeps doing that. It snakes in. So all of this is automated. Now we come in because we're nerd scientists and say, hey, that's cool. We saw something over here. A drone dropped 500 feet. And we tell it to do something. So we can do both, is what I'm saying, Bill. But I think in the future we'll have an operational kind of standard, and then we'll have maybe a research version of it where we do what we want.
Yeah, my imagination takes me, there'll be somebody sitting at a desk at NHC with a display and some toggles like a video game, and they'll be running the drone from the center.
100%. We want to get everyone off the plane where we just have someone deploy it like we do a dropson. And then that is actually our vision. We have a remote centralized place maybe where we you have all the everyone there. But even that you can VPN to, let's say, and you don't even have to physically be there. So we are definitely planning to do all of this from the ground. Probably, I would say, where we're doing this routine, like you just said, with toggles and people being able to do it from NHC, probably a good 5 years from that. But we'll probably doing prototyping of that maybe within the next 2 years. So to get the system together, because it's a lot of it's technology, communication, kind of boring stuff, really. But the vision is there for that for sure.
Yeah, communications from the air has always been a challenge.
It sure has. It really has.
Tim, you look like you're ready to bite my hand if I start talking again. Your turn.
No, just the mind-boggling technology. Just listening to this is just blowing my mind about what, and we've been talking about this, you've been talking about it with the show for years about this, but it seems like every time we talk, there's just another advancement. And all of this to say that hurricane forecasts are going to improve because of what you guys are doing.
Yeah. Well, thank you. We're really happy. We got a team. It's not just me. We call it Emergent Technologies team. And by the way, I can delve into some other stuff. Like, for example, we have drones now that we're designing with companies. We're working with them to work from the stratosphere, and that they would essentially be able to think of like the Global Hawk from many, many years ago. But this thing stays up weeks to months and is solar powered, much lighter, about a 30-foot wingspan, solar panels, and only weighs about 45 pounds. So this thing is big and light. Just think of sort of an albatross right up there. And we have microsons now, so that I hinted before, we have this next generation dropson called Streamson. They're only about 15 grams. Actually, that's heavy now. We can get them down to about 12 grams. And that drone I was telling you about, built by a company that's in the UK and the United States called Strato Solutions and Voltitude, they have two names. And they are in the prototyping for this HAPS system. It's the high altitude satellite, proto-satellite, they call it, I don't know, whatever the name is, HAPS. But it will have about 100 or 150 of these microsons that it would drop. Can you imagine it just going over a hurricane and just deploying at will, and you're getting the entire depth of the troposphere this time. And you can pressure, temperature, wind, humidity, of course. And that's what's next for us. So this is not a penetrator drone, but it's sort of an omniscient drone. Or think of it this way, where it's stay weeks, we catch a wave coming off Africa, and then we just go. Very complicated to get everything working right, including the clearances and the FAA and other airspace stuff. Again, sort of boring stuff, but necessary stuff. And that's what we're working on over the next few years. And to test this prototype is probably going to be in 2028 I'm going to guess over sort of a wave system coming off Africa. They're doing other things before that, but that's the first time we're interested.
Absolutely amazing, fascinating stuff. And I think when the public doesn't realize how much is going on behind the scenes. They have no clue. We have no clue. I should include ourselves in this because so much is going on. Well, leave us with the final thought from what you're doing today. Now we know where you've been, where you're headed. Do you have any final thoughts about the research division, everything you're doing over there?
Yeah. So, I think we are making gigantic strides. We, the community, I think AI should not be looked at as something scary. And a lot of people are like, it's challenging what we do. You know what? That's good. It's good that we're challenging what we do. And I think that that's coming whether you like it or not. Embrace it. We're trying to look at it in a different sense to help us optimize how we sample, right? We're doing eyewall right now. Well, is that the best way to do it? What gives us, where is the uncertainty, and how do we use this new technology to help us with limited resources? We're always in a limited resource environment. There's great advancements in the numerical world to HAFS is going on to its next generation. HRD has developed these single base, one base a model that we can really look at multiple storms wherever it is in the globe. Our advancements in emerging technologies ongoing. It's so rapid I can't keep up with it really. Maybe on our next show we'll be able to do it, but I think the future looks incredibly bright for all of this. And hopefully I'll be able to come. I wasn't able to get out there this year, but for 27 I'd love to come out to the conference and show you guys what's new and imagine how much is going to happen in the next 10 months or so. So we'll have a lot to share.
I love it. Bring one of those drones with you so you show it off. That would be awesome.
I will.
That would be awesome. Bill, what did we learn today?
We learned that we can't cover everything we want to ask in 30 minutes. I got this whole sheet of questions, and Joe, we only talked about one of them, but it was absolutely fascinating.
Yeah, I hope that's okay. I didn't mean to. Maybe I should.
Yeah, probably much to Alex's dismay and maybe Tim's is I go off script all the time. I don't know how to follow a script.
That's what makes this good, Bill. We appreciate that. Hey, we appreciate our sponsors week in, week out. They're here for us. USAA, the South Padre Convention and Visitors Bureau, Live View, and the Texas Weather Network. And Joe, we appreciate you taking time to be with us. We look forward to having you back and to seeing you at the other Hilton Garden in April of 2027. Thanks, Joe.
Yep, really looking forward. Thanks, guys. Always
appreciate it. Thanks, Bill. Thanks, Alec. That's another program. Next week, Andrew Feemath from USAA will be with us. We encourage you to join us again next week. That's it for Season 7, Episode 144 of Hurricane Center Live. Take care.
Take care.